Let's use the rational root theorem to list possible rational roots of a polynomial. Let's get started. Use the rational root theorem to list all possible roots of the given polynomial. Then use various methods to determine the actual roots of the given polynomial. So our polynomial is p of x. And I notice that it is listed in descending order. And so first they want us to list all of the possibilities in terms of rational roots. And then part B, they want us to use synthetic division or any other method to determine the actual roots of our polynomial p. So let's identify the coefficients that would be p and q. P is the constant term and q is the leading coefficient. So let's set up p over q. P over q. So p is 20 and q is 1. So we're going to list all of the integer factors of p and q, 20 and 1. So that includes positive and negatives. So if we go off to the side here and factor 20, we get 1 times 20, 2 times 10, 3 is not a factor, 4 times 5, and then we go back up the other side. So we have 1, 2, 4, 5, 10, and 20. Those are the factors of 20. So let's list those positive and negative counterparts in the numerator. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. So 1 is the only factor of 1, so we're going to list plus or minus 1 in the denominator. Now, we only have one factor in the denominator, actually 2 if you count plus and minus, but we're going to create a fraction out of all of these possibilities above. We're going to have 1 over 1, 2 over 1, 4 over 1, 5 over 1, 10 over 1, and 20 over 1, as well as the negative possibilities. So let's just list those as our answer. Plus or minus 1, because we're dividing, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Those are possible rational roots. Rational meaning they can be expressed as a fraction. Anything over 1 is a fraction. Now, we need to test these possibilities. Let's look at them. 2, 4, 6, 8, 10, 12. We have 12 different possibilities, and we need to start testing them. And this is a good start for looking for our rational roots. Rational numbers are real numbers. So these are the possibilities from the real numbers. So we're going to use synthetic division. So we're going to see if positive 1 is a root. So we put positive 1 in our multiplier. We're going to take our coefficients, 1, 10, 29, and 20. And so we're going to add or subtract, starting off with nothing. 1 and nothing is 1. Then we're going to use our multiplier. Times 1 is 1. Add 11. Times 1 is 11. Add 40. 40 times 1 is 40. And then we add and get 60. We get a remainder of 60. And so the remainder theorem says if the remainder is 0, then the number that you used is a 0. So this is not a 0. Okay? So now we tried positive 1. Let's start over and try negative 1. Same coefficient, starting over. Starting off by adding nothing. Our multiplier this time is negative 1. So the signs will change. Negative 1, 10 take away negative 1, or 10 minus 1 actually is 9, times negative 1 is negative 9. 29 minus 9 is 20. 20 times negative 1 is negative 20. And this last number, 20 minus 20, is 0. We have a 0 remainder. And if we have a 0 remainder, then what we plugged in must have been a root. So negative 1, x equals negative 1 is a root, a 0, an x-intercept. Those are all used interchangeably. So if that is our root, then our factor looks like this, x plus 1. Okay? And so we started with x to the third power, and we divide it down by 1 power of x. So that leaves us with x to the second power, x squared, on our bottom row. So this trinomial, we're going to check to see if we can factor. So let's reveal that polynomial first. X squared plus 9x plus 20. And so, and we make sure we bring down the factor that we found. So, factoring this trinomial into two binomials, x and x for x squared, 4 times 5 gives us 20, and 4 plus 5 adds up to 9. So we have factored p of x, and since we have all of the factors, then we know what the roots are. So the actual roots, if these are the factors, the actual roots would be x equals negative 1, x equals negative 4, and x equals negative 5. So when we go to our answer blank, we will enter negative 1, negative 4, and negative 5.